Hello everybody and welcome into another visual effects demo. Today we are going to be diving straight into the material graph, and I'm going to be teaching you guys how to create your own materials using some pretty basic techniques. Before we begin, I'd like to start by showing you guys some of the textures that I have here today, just to show you what we will be working with. So as you can see, I have a pretty standard sort of square texture. It's 1024 by 1024 and it's in black and white. And we are going to be working with flares. So flares are most commonly used in impact frames, but really you can use them in any sort of application that has anything to do with light. So anything with glows, anything that flashes, you can pretty much use your standard flares in order to make that visual effect pop. Here I have a more realistic looking flare. You can see it has a very bright center, some gray volumetric glow, and a lot of sort of details within that shape. So overall, this is going to produce a fairly realistic looking visual effect. And I have a few of them here. Some of them are just lens flares or camera imperfections, but most of them are flash frames that you can use for any kind of impact or spark or flash. So let's begin. To start, I'm going to create a material folder. And within that folder, I'm going to create a masters folder where I'm going to store all of my master materials. And to create a material, you just have to right-click anywhere on the content browser and choose material. It'll create an asset right there, and you can rename it to M for master, underscore emissive underscore translucent, because that's the sort of the nature of this particular material. And I'm going to double click that and it'll take us to the material graph interface. Now to start, I'm going to do some split screening here just for the sake of this demo and the sort of the visual aid. When you go into the material graph, you're going to notice two things. Number one, you have your output node here. It has all the basic sort of outputs that the shader will use to render your material. And then you have the material details where you can access a lot of the settings and properties that allow you to customize this material. And for this particular demo, we are going to focus on two options: the blend mode and shading model. Now the blend mode is just like if you've ever used Photoshop and accessed layer styles like color dodge or multiply or overlay. Blend mode works the same. It kind of just affects how the engine renders your material in the level. And for this application, we are going to use translucent. So translucent doesn't have access to the MSR or the sort of the metallic, specular, and roughness options for the outputs. It will rely mainly on emissive and opacity. And then for the shading model, here we are going to, by default, it's going to be on default lit, which accepts light. But for us, because we're spawning so many of these particles, we're going to want to disable that for performance reasons. And so we're going to turn this into unlit. And that leaves us with emissive and opacity, which is sort of the only things we need to do for an effect like flares or like flashes. We only really need to control these two properties here. So to start creating my graph, every time I make a new material, I always start with the texture because that is the driving force of our visual effect. And so I'm just going to choose a flare here and sort of drag and drop it in there. It'll create this texture sample node. And from here, we have two ways to go. There is the left-hand side of our material graph, which essentially is where we will do our UVs, and the right-hand side of our material graph, which is where we will do our value control coding. So I like to work from left to right, and so I'm going to start with the UVs. To start, I'm going to look for the texture coordinate node. So you could find it by right-clicking and then looking up texture coordinate. And this is an Unreal input or Unreal variable that basically tells the texture how to wrap around a certain mesh using its UV information. So it's going to take the UVs of any kind of mesh that this material attaches to, and it's going to tell your texture, okay, this is how you wrap around that. And for this particular shader, for this particular material, I wanted to do two things. Number one, I want it to be able to scale, so I can scale it in and out. And number two, I want it to rotate. And so I'm going to start with rotation, with scaling first, and then we'll move on to rotation. So to be able to scale this texture, Unreal has a function called scale UVs by center. And this is very useful whenever you want to adjust the size of your textures on the fly. This function accepts two inputs. Number one, you have your UVs, and then texture scale. The UVs, this one will use the texture coordinate that we access. So I'm just going to plug this in here like so. You take the pin, you plug it into the input. And then texture scale accepts a float. So when it says V2, that means vector 2. And so that usually means it accepts any kind of number that has two variables in it. But for us, because we want it to be uniform in scaling, we only need a singular float. And so for that, we are going to use a scalar parameter. You can right-click and look for scalar parameter. And I will rename this into texture 1 scale. And then for the default, I'm just going to use 1 for the default scale. And so that is going to be a multiplier for the scaling. So I'm going to plug the UV output to the texture sample like so. And then I can go ahead to preview this. I can go ahead and plug in the red channel of my texture sample to the emissive color of my material, just so we can see what's happening here already. Now, if I begin scaling this, what you'll notice is that it starts to tile. We don't want this, mostly because that doesn't look right, and it's not giving us the effect that we want, which is just scaling, making the texture larger or bigger, depending on our use case. And the reason this happens is because textures by default, when you import it into Unreal, they're set to wrap around, which is very useful when you have patterns or noises, but not as useful when you just want to scale your mask textures. And so to change that, we are going to access our texture here. So I got here by double-clicking my texture asset, and it's going to take me to this interface where I can see sort of the texture details here, and I can fiddle around with some of the settings. So you're looking for underneath the texture section, you go to advanced, and then you find this X and Y axis tiling method. And by default, this is going to be set to wrap. So you're just going to have to set it to clamp like so on both sides. And then now when you go back to your texture, you're going to see that you're going to be able to scale this to be smaller or larger, depending on your use case. So now we have scaling. So that's good. Now that we have scaling, I'm going to set the default of this back to 1. Now that we have scaling, next we can do rotation. So for rotation, there's another Unreal Engine function that we can use called custom rotator. And just like scale UVs by center, custom rotator also accepts a UV input. That's how it manipulates the UVs. And so I'm just going to go ahead and plug my scaling into this rotator. So this UV node here, I'm just going to click it and plug it here. We're not going to be worried about the rotation center. You could if you just want to change the pivot. But right now I want it to be perfectly uniform, so I'm not going to touch this one. Instead, I'm going to go straight ahead to rotation angle, which you see here accepts a scalar, which is a single float, which is this one. Another way to spawn in a scalar parameter node is to just hold S on your keyboard and left click anywhere on the graph, like so. And then, so now it automatically spawns one in and you could rename it immediately to whatever you need. So for this one, it's going to be texture1 underscore rotation. And I can go ahead and plug this in here. And what you'll notice is when I start to adjust this here, it starts rotating. Oh, sorry, I forgot to plug this into the UVs. Rotated values goes into UV of this texture. And now I can start rotating it clockwise or counterclockwise. So the issue here is now it's a little bit static, right? I can only really rotate this. I want it to animate indefinitely. So I want it to keep rotating and animate like that. And so for that, we are going to need a time node. So time is another red node, which means it's a constant Unreal Engine node. And if I plug this into rotation angle, you'll see that it'll start to rotate counterclockwise. And so that's very useful for animating different properties of the textures over time. And so you can basically apply this to anything. But for now, we're going to be using it for rotation. Obviously, we want to be able to control the speed of this. And so we're going to need a speed multiplier. And for that, we're just going to take the scalar parameter that we made earlier, create a multiply node, and multiply the two values. So texture rotation goes into A, time goes into B. And so that means texture rotation times time equals rotation speed. So right now this is set to 0. If I set it to 0.1, I can make it spin counterclockwise. And if I set it to a negative value, I can make it spin counterclockwise. There you go. So now we have an entire texture that we can use to be rotating or to scale however we would like. And so that's great. But for me, I want this effect to also have functionality that it can have two textures that are rotating against each other in different speeds, so that it gives us kind of a shimmering kind of light effect. And to do that, I'm going to need 2 copies of this same code. So instead of typing it all out, one more time, I'm just going to go ahead and select all of my nodes and hit Control D for duplicate. And now I have 2 copies of the same thing. I'm just going to go ahead and rename all of my parameters. So texture 1, I'll rename to texture 2. Texture 2, I'll rename to, texture 1 rotation, texture 2 rotation. And then I'm going to parameterize both of my texture sample nodes. So I'm just going to go ahead and convert this to parameter. I'll name this one texture 1, and this one I'll rename texture 2. There you go. So now I have 2 nodes. I want to combine both of them. And to do that, we are going to use another multiply. So if I just wanted to combine both of them, I could just like multiply them like so. And if I plug this into emissive, you'll see that now they're combined. And so I can, rotate one texture one way, and then rotate the other texture the other way. And then now we have this sort of shimmering light effect going on with our material. So now that that's well and good, this could be our alpha, but we need some kind of way to sort of manipulate those gray values, adjust the levels a little bit to maybe have more detail or have a little bit more volumetric glow. And so for that, we are going to use a power node. We're going to use 2 of them actually. To be able to control both of the textures separately. And so what the power node basically is an exponential node. So it's going to take whatever you plug into the base, and it's going to multiply it to itself over and over, depending on the number of the exponent. The higher the value, the more choked off the white values get. And the lower the value, the closer you get to 0, the more washed out it's going to look. So to show you that, we are going to plug in the base. Plug in this base. Red channel to base, red channel to power, and then power nodes to the multiply. So now this is what my graph looks like. We are going to want to control these power nodes with parameters of their own. So for that, we could use scalar parameters, like 2 separate ones, and then plug them into the separate power nodes. But for me, I want just the one node to control both of them. And so I'm going to use a constant 4 vector. And you can look for that if you just right click and then look for constant 4 vector. There you go. It's the same thing. Or you could just hit 4 on your keyboard, hold 4, and then hit left click anywhere on the graph, and it'll spawn the same kind of node. And what this is that it's a color node with 4 pins, RGBA. So as you can see, it is red, green, blue, and then the last one is alpha. And this gives us 4 channels to be able to control different parameters of our material. So I'm just going to go ahead and convert this to parameter. I'm going to rename it to texture values. And then I'm going to set the default values to 1. I could set both of them to 1, 1, 1. And then I'm going to rename the channel names, because so the channels are these pins that we are going to go plug into our power nodes. And so we want to rename those so that we know which one does which. So the red channel is going to go into the texture 1 power. So I'm going to rename that into texture 1 underscore power. Same for the green channel. I'm going to, because the pin is going to go into the sort of texture 2 power, I'm going to rename that into texture 2 power. There you go. And then I'm going to plug both of those into their respective power nodes. And so now we have a way to control the values of our textures separately from each other so that they're kind of independent. There you go. So now we have our UVs, and now we have our alpha controls. Next, we are going to do tinting, which is essentially just taking a color and then multiplying it into your alpha, which is this one. So to do that, I'm going to get a vector 3 node, which is similar to the vector 4, except it doesn't have alpha. So I'm just going to show you, I'm going to get a vector 3 node. Pick any color I want. For this one, maybe I want, gold. And then I'm going to multiply this vector 3 to my alpha texture. And then I'm going to kind of move this. I'm going to go ahead and put in an eye adaptation function. So the eye adaptation is basically just an exposure, an auto exposure node that happens on the material level so that you don't have to tweak the post processing. And to do that, all you have to do is look for divide. And then you're going to take your emissive, plug it into A, and then you're going to look for eye adaptation, plug that into B, and then you're going to plug this divide into the emissive color. And now you have a color tinting. So now I can, change this color to whatever I want, and I'll have good color. Now we have color functionality. The problem that we have here is that this is not dynamic, meaning it's a static value. We are going to have to go into the material every time if we want to have a different color. And so that can get, very unwieldy very fast. And so we want to be able to modify everything within the particle system. To do that, we are going to use a particle color node. And so particle color is just another sort of input node that Niagara can access. So from here, I'm going to just, as you can see, it's already named RGB, and then the different channels are named. And so I'm going to go ahead and plug the RGB channel into my multiply in place of this color. And then I could go ahead and delete this because I'm not going to be using it anymore. And so now what this does is it allows us to control this material in Niagara moving forward on all of the instances that we are going to be creating. So now we have dynamic color. Right now, all that's left is to sort of get rid of this dark square. But so before we do that, we could just sort of plug this multiply into opacity. Once we do that, the dark square will be gone and you're left with just the white and gray values. But so what you'll notice is, and just to demo this real quickly, I'm going to go to shapes and I'm going to I'm just gonna put in a plane. And then I'm gonna go to where this material is. Oh, I'm gonna hit apply first. And I'm going to apply this to the material. So you can see there it is. Now it's applied to the plane. What you're going to notice is that if if this material ever comes into contact with the floor, you'll get what's called a seam. So as you can see, where the material kind of clips into the floor, you can see that line. So that seam is going to make your visual effect look a little unpolished, and it's going to look unfinished. And so we want to get rid of that seam. To do that, we need a function called depth fade. So depth fade, what this does is it detects that seam, this intersection, and it's going to do some calculations to be able to fade that intersection out, so there's not going to be any sort of sharp lines. And so from here, it's pretty simple to apply. You just get your multiply for the alpha, like for your textures. You're going to plug it into opacity. And then you're just going to plug depth fade into the opacity of the material itself. So like so. And then this fade distance, it accepts a float. So you could also use a scalar parameter for that one, which I'm going to do. So I'm just going to use a scalar, name it depth fade. And I'm going to put in a sort of a small value like 25 into the fade distance. And I'm going to hit apply. And so now what you'll see is the seam is now faded out. So the line isn't as sharp. And so that's going to look much better when you create your visual effect. Last thing we need to do is to add sort of a dynamic way to control the alpha as well, so that we can fade this particle out and have sort of a fade out effect in Niagara itself. So what we're going to do is same thing with the color, how we tint the color. We're just going to create a multiply, take the alpha of this particle color and plug it into A. Take the multiply of our textures, plug it into B, and then plug this multiply into depth fade, like so. So now when I hit apply, it's not going to change anything, but now we have a dynamic material that we can use in our visual effects. I'm just going to go ahead and set the rotation back to 0 so that it's all default. So it's going to be static, it's going to be neutral, and then we can modify our instances from there. So now this is what my graph looks like. As you can see, we have the UV controls here, our textures here, with the value controls, and then we have tinting with our emissive, and then dynamic opacity controls here, also controlled by the particle color node. And so that's the very basic setup for translucent materials. And so next we are going to dive into creating instances for this effect. For instancing, what we are going to do is to go ahead and, well, I'm going to save this first just so I don't lose it. Always save, you guys. Now we are going to create instances of this effect. So essentially what we'll be doing is creating children of the master material. To do that, we are going to go ahead and look for our material. Mine is right here in the masters folder. And I'm going to go ahead and right click it. And from here, I can see create material instance. I'm going to go ahead and click that, and it's going to create another asset for me. And as you can see, it's labeled. So this one is labeled material, and this one is labeled material instance. And so for this one, I'm going to name it to MI for material instance underscore whatever the use case is for this that I'm going to use this instance for. So I'm going to rename it to MI underscore flare underscore 01. It's very important to keep your file names straight and consistent so that you're not fumbling around and looking for your assets in your own projects. It's not going to get lost anywhere, and you'll always know what it does. It's also important when you start working in teams because more often than not, you're not the only one who's going to be touching these assets. And so it's important that it's readable for everyone else as well. So that's just a good bit of practice that you can do to make sure that you are operating on all cylinders. So anyway, I'm going to go ahead and take this flare and I'm going to move it out of my masters folder because obviously it's not a master material, so I don't want it there. I'm just going to move it to my material folder. I'm just going to move here and it's going to move it back to the material folder. And from here, this is I can double click this to open it and access the material instance interface. And as you can see here, I have all of the different sort of parameters that I've exposed earlier. And now I can start making variations of that one master material. So for example, flare 01, maybe I want to keep it mostly the same, right? So I'm just going to make a depth fade, and then maybe I'll adjust the scale a little bit. Maybe I want to have a little bit of rotation, right? Maybe I want a little bit more volume for this one, right? So, and then, just to preview that, right? So maybe I want something like that. And then if I want a different kind of texture, if I want a different kind of material, I can go ahead and duplicate this flare. Same thing, you left click it, hit Control D, and then it'll just make another copy, right? So, and then I can open this one, and then I can go to my textures and, look at my different flare options that I have, and maybe I want this one next. So if I want to preview that, right? And so now I can just start creating different variations of the same texture and material over and over for as long as I have textures, like different textures to work with. And so now we have we can have a wide variety within our library. We can start developing our material library so that we have all kinds of materials to work with to create our visual effects. So for me, I'm just going to go ahead and start creating like different flares, different glows, right? So I'm just going to go ahead and double click this. Maybe I want embers next, right? Maybe I want a different kind of thing, right? So maybe I just for ember embers _ 01, I'm just going to use this, right? I'm going to turn off rotation. I'm going to turn off scaling, right? So I'm just gonna set that to right. So now I have 2 of them. So now I have embers, which is great. And we can have sort of a bunch of different things, a bunch of different translucent materials from this one master material that we've created. And so that's going to be useful when we start going into Niagara next. So we'll be tackling that in the next video, but for now, this one is pretty good. So see you guys next video. Bye-bye.